Okay, so this video is going to be for our first example for this week's lab. Basically what we're going to be doing in this question is we're going to be drawing an elevation of a plan of a square base pyramid. Now the thing about this to make it that bit tricky is that it's going to be inclined, and it's going to be inclined both to the vertical plane as well as the horizontal plane, and all the information in relation to that you can see above here in the question itself. Now when I break down the question, first of all I also want to show you this model here when I'm talking about it, just to give you a visualization of the solution in a 3D model while we're talking about it here, so you can actually see where each part of the question is linked to the finished solution. So we'll start off. One side of the square of a square base pyramid is first inclined at 30 degrees to the vertical plane. Okay, so we have our square base pyramid, so you can imagine just a normal square base pyramid. It is inclined 30 degrees to the vertical plane. So where's our vertical plane? Our vertical plane is back here. So that means, looking at our square base pyramid, it's going to be rotated outwards like so, below one plane. So as you can see here, the line that's touching the horizontal plane here, this one, is actually not running parallel to the XY line, or the representation of the XY line here in our 3D model. It's actually off at 30 degrees. That's what it means by this inclined 30 degrees to the vertical plane. Now if we go down here to the other things to note, the base is inclined at 30 degrees to the horizontal plane. So if we look at our horizontal plane this time, not our vertical plane, it's also inclined at 30 degrees. So now not only is it inclined like this to the vertical plane, it's also inclined upwards like so to the horizontal plane. So as you can see here, it's tilted upwards. Okay. And then the rest of it is just give you some measurements in relation to the square base pyramid. So the side of the square base pyramid are 40 millimeters. So that's basically each end here is going to be 40, like so. And the altitude of the square base pyramid is 70 millimeters. So that's from the base all the way up to the top, looking dead on from the side. Okay. So now that we've that information, what we can do is we can start tackling our question. Now, the first thing I want to talk about before we kick things off is that to draw this, what we're going to have to do is we're going to have to think back on some of the knowledge that we gained through our junior cert cycle. So think back on rotations. So what we're going to need to do is draw the square base pyramid like normal in elevation, or sorry, in plan first of all, and then we're going to take an auxiliary view, and then we're going to incline it at 30 degrees. The first square that we draw can be inclined to the vertical plane because it's lying flat on the horizontal plane, so we can still draw it as square that's just 30 degrees offset. And then when we have our auxiliary, we can draw it again over here, which would be our auxiliary elevation. And then what we can do is then rotate that 30 degrees. And then we've rotated, we can bring it back, bring in the final outline of it in plan, as well as the final outline of it in elevation. Now, if you're not sure what I was on about there, don't worry, I'll be working through it step by step. So if we start off by drawing our square as if it's sitting down on the horizontal plane, okay? Now, this is all light because this is not going to be the finished product. We know it's 30 degrees to the vertical plane, so I know that I can use my 60-30 degree set square here to draw a line at 30. So measure it, it should be 40. So then you have square drawn in, and it's inclined to your 30 to your vertical plane. Then what we can do is take an auxiliary view down this direction. You could also take it up here. I'm just going to take it down because there's more space. So you have a line that's going to be parallel to the side of it. So call it x1, y1. Take our lines across. like so. Now there's no need for me to extend that. And I also then have to take basically the center of our square base pyramid as well. So I should have that found. I'll just cross the diagonals. So take that over. And then I have to use my altitude above here. 70 millimeters, 7 centimeters. So knock it off. Finish off my auxiliary elevation. Now, again, you'll be keeping this nice and light. I do a bit heavier so you can see it nice and clear here in the video. Now that I have this drawn in, what I can do is I can actually tilt this, or rotate it, sorry, 30 degrees. So this XY line basically, it's like it's going to be moving to here, the object itself, to the XY line, and then it's going to be off an angle. Then I can bring it back and reconstruct it in my plan and in my elevation. Now to do this, I'm going to need a point that I'm going to be rotating from, or the center of rotation. I'm going to use this point here because I still want this side here, or this line here, which is represented as a point here, to be touching the horizontal plane. Now I'm just going to call that center of rotation. I'm just going to call this an auxiliary elevation. We'll call this my elevation. And I'm going to call this my plan. Now what I can do is I can rotate it. First of all, I'm just going to make sure that it's offset at 30 degrees. I don't need my, oh no, sorry, I do. I need to use my set square here, like so, line it up, back off 30. Draw the line like so. So basically I can rotate any point here up so that it hits here to its new location. Now usually, depending on how big the drawing is, I'd like to letter or number annotate basically the different points so I don't get confused. This is nice and simple. If you find it handy to annotate, do, by all means. If you find that it's nice and simple and there's no need, then don't bother. But the one thing I would say, if you're teaching this to, let's say, a junior cert cycle question, if you're using this as a junior cert cycle question, or even using it for a week class of 5th or 6th year students, I would suggest you'd still annotate the different points. Just make it very, very clear any point you're talking about. Now what I can do, I'm going to have a line here that's going to be perpendicular to this one, traveling out, and then I'm going to basically swing my arc here, which is keeping my 70 millimeters basically, and it's then going to give me my new position. Should be 90, yeah. Hopefully I have enough space. Yeah, that's perfect, works out. So you can see I rotated that over as well, using my basically my center of rotation. You can see that all these were rotated across as well, like so. I have my new location here. I'm actually going to put this in a bit heavier so you can clearly see the outline of where the square base pyramid is now. And now what we're going to do is basically bring it back along. So now that we have it rotated here, and this basically showing our inclination from the horizontal plane, bring it back here and then bring it back into our elevation. As you can see, when this was rotated, so when it was rotated over like so, the apex here, the very top, is now located over here and not here. So as you can see that this point is now going to travel back to here. And you can see where the end, so basically these two corners here, they've rotated up, so now they'll be ending earlier here. So I'm just going to draw that in. Still located in the same spot. And now these corners here, as you can see, they join up to the apex as well, so they'll be brought straight up. Now it's not as clear in my one that this line here should be light because it's actually behind, it's like hidden detail. Like so. Now what we can do is we can bring it up into our elevation. First of all, take up the two, or basically the line itself, the two corners that are going to be sitting on the horizontal plane. Now these two are going to be a small bit above the horizontal plane, because remember it is now going to be inclined like this, inclined upwards. Take our distance. They'll both be the same. Then we have to locate our apex up. Now again, just be nice and careful what's in detail and what you can actually see. If you like and you want to practice and you want to complete this question yourself, I'll have it anyway above in the resources on Solus, so you can download it and complete it. As well as that, you know, for things like this, if you're explaining it, it might be handy to bring out pro markers like these ones, different colors, shading the different surfaces, so that the student can then recognize, okay, this green surface here is related to the green surface down here. Actually, that wouldn't be a good one to do because it's actually hidden below here. So let's say we say color this surface green and then have it green below here, and then they can relate the two surfaces. or as well as that, you could have, let's say, this one here in red, and then you bring it over here and put it in red here so that they can make the links between the different ones.